Okay, today we're going to start lesson 8.3.1, polynomial division, and I am going to read a little bit from the book just so you can really hear how they're going to ask these questions and what they're getting at. When you graphed polynomial functions in the first section of this chapter, you learned that the factored form of a polynomial is very useful for finding roots of the function or the x-intercepts of the graph. But what happens when you do not have the factored form and you need to find all of the roots? That's what we're going to be investigating in this lesson and in 8.3.2. Okay, this question right here, 8-113, Andre needs to find the exact roots of f of x equals x cubed plus 2x squared minus 7x minus 2. When he uses his graphing calculator, he can see that one of the x-intercepts is 2, but there are two other intercepts that he cannot identify exactly. Okay, he remembers that he learned how to multiply binomials and other polynomials using the area model. He figures that since division is the inverse or undo operation for multiplication, he should be able to reverse the multiplication process to divide. As he thinks about that idea, he comes across the following news article. We're going to get to the news article in a little bit, but let's talk about this. I know some of you are looking at this and saying, I can find the roots. Let me just throw that into my calculator. Okay, I get it. And you can easily see that it crosses 3 times. It's a cubic. It has 3 real roots. Okay, you can look at your table and you can find that 2, 0 is one of the x-intercepts, but you cannot easily see the other ones. Okay, I know lots of you would say, okay, just hit second, trace, or trace in general and figure out where those 2 other points are. But I promise you that those will not give you the exact answer. It will just be approximate. Okay, so we want to be able to use polynomial division in order to find the exact roots of an equation. So again, what did we see on the calculator? We saw that for sure the graph crossed at x equals 2. And remember, that tells us that x minus 2 is one of the factors. We want it in factored form. It's easier to graph by hand in factored form. Okay, so we have to figure out, well, what else is here to multiply by x minus 2 to get us to this? That's where polynomial division comes in. Okay, so your next job is going to be to pause the video. You're going to read 8-113, okay, the news article. We just did the beginning part of 113. You don't have to do anything with this, just read it. You do need to do 114 and 115. It works you through some exercises that get you ready for number 116. Okay, so for 116, this is just showing you how do we divide polynomials, okay? Polynomial division. And they call it in the book PolyDuco. I show PolyDuco, but I show it slightly different than a lot of the other teachers. So if somebody else has taught you this concept of dividing polynomials in a different way, it's okay. You have to be able to show your work. You have to be able to explain your work. But if you don't do it exactly like me, it's okay. Okay, so let's go back. Let's think about our generic rectangle. In Algebra 1, we did some basic stuff like this. And these two things multiplied together is the product. What's inside was the sum. So over here, the top is actually the sum. The top is what would be added up on the inside. The bottom is one of these factors. So I'm going to do just that. I'm going to start with whatever's on the bottom, goes along the left side of my generic rectangle. I don't know how many boxes for sure this is going to be, so I'm just going to leave it open-ended. I do know that this top part is really what's going to go on the inside when I add things up. So I'm going to start with the biggest degree. The biggest degree here is 3, or the biggest exponent, I should say. Okay, so 6x cubed goes next to the biggest exponent of this. Okay, I'm going to think backwards. What times 2x gives me 6x cubed? Well, 3 times 2 gives me 6, and x squared times x gives me x cubed. Of course, in a generic rectangle, we have to fill in all the spaces on the inside. So when I multiply these things together, I get 15x squared. Okay, now I have 6x cubed. I'm going to just check that off. Okay, then I'm supposed to have 7x squared. However, I have 15x squared. So I have to think 15x squared plus what will get me to 7x squared. Okay, If I add those two together, they are like terms on the diagonal. When I add them together, I get positive 7x squared. That's what I was supposed to have, okay? Thinking backwards, negative 4x times 2x gives me negative 8x squared, okay? And then, of course, I have to fill this in. I get negative 20x, okay? Then, it's not supposed to be negative 20x. It's supposed to be negative 16x. So negative 20x plus 4x gives me negative 16x, okay? Work backwards. 2 times 2x gives me 4x. 2 times 5 gives me 10, okay? I have 10. I'm supposed to have 10, so I'm good. I'm actually done. So when I divide these two things, what do I get? I get this answer that's up here on top, okay? I get 3x squared minus 4x plus 2, okay? Another way to write that is product sum. What's the product? 2x plus 5 times 3x squared minus 4x plus 2. What does that equal? It equals the sum that's in the middle, okay? 6x cubed plus 7x squared minus 16x plus 10. Okay, so there's my answer. This is how I use PolyDoku to do polynomial division. Okay, then in question number 117, it says, whoops, Jessica made a mistake. Okay, and her mistake wasn't in calculating the problem. She just did what we've all done before. She copied the problem down wrong. So instead of 10 here, what if it's 18 here? Okay. So let's see what happens. Whoops, I probably should have kept that, but that's okay. So what happens? It's the exact same process that we've just done. Everything's the same up to this point, okay? We still have negative 16x here. We still get 2. We still get 10. But it's not supposed to be 10. It's supposed to be 18, okay? So 10 plus what makes 18?
Hey, Mom.
Thanks, Thomas. Just put it on the counter, buddy. Okay, so now I have an 8 and a 10, which would add to make 18. Now, it doesn't make sense to say 2x times what makes 8. And if you notice, this is 3x squared minus 4x plus 2. Once you get to the constant, you're done filling things in here, really. Okay, so how is this answer a little bit different? This is 3x squared minus 4x plus 2. That's still the same, but now we have this remainder. Okay, so this is a remainder of 8. Okay, but there is a better way to write it, and I want to show you guys the better way to write it. Think about if you did 9 divided by 2. Okay, and I know this is a super simple example. You could say that this is 4 with a remainder of 1. But normally what we really say is 4 and 1/2. The 1 comes from the remainder, the 2 comes from we were dividing by 2 to start with. So instead of saying remainder 8, we still say 3x squared minus 4x plus 2 plus 8, okay, the remainder goes on top, and what goes on the bottom is whatever we were dividing by to start with, okay? So this is our solution for Jessica with a plus 18 here. If this was plus 10, there's no remainder, you just write this. But when there's a remainder, you put it over top of whatever you were dividing by.